The infrared spectrum of an organic compound is shown. Which compound could produce this spectrum? So we've been given a choice of but-1-ene, but-2-ene 1-ol, butanoic acid, and butan 2-ol. So what we need to do is look at the spectrum. The first thing I'm going to do is I'm going to draw a line at 1500 and I'm going to get rid of the fingerprint region because we can't use the datasheet to help us interpret the fingerprint region. We're then going to look at the other parts of the spectrum and look at the characteristic absorptions that we can see. So what's this peak? What's this peak? And to a lesser extent, what's this peak? So we're going to use the datasheet, a very sharp peak between 16 and 1700. That is going to be a C double bond C. So we're going to eliminate D immediately because it doesn't have a C double bond C and C. Then we've got around 2800 to 3000. That is where we might find our CH peaks. So that's less helpful. And then between 3200 and 3500, and looking at quite like a finger shape, that is an OH in an alcohol. And that then tells us that we've got both a double bond and the alcohol group. So we've got B, but-2-ene 1-ol. If we'd have had A, then the peak for the alcohol would not have been present. If we'd have had C, we wouldn't have the C double bond C. We would have had a peak quite close to there for a C double bond O, but our C double bond O peaks are usually a little bit broader than our C double bond C. And the other way we'd have been able to tell, so when we got back over to where the CHs were, they would have been kind of jagged into the edge of the OH peak, and the OH peak for carboxylic acids is much broader and has a kind of jagged edge. I always think it looks a bit like an upside down mountain. That would have been C. D would have had wouldn't have had a peak over here at all and would have had a much smoother peak for the OH, and then similar to this had the CHs separately. That would have been D.